Hey, how's it going? This is Ed with SGU TV. That's right, and it's time for another episode of us to learn some things. Today we're talking about tumors versus the immune system. Let's get it on. Alright, so the first thing we want to talk about is, tumors and how they start. We're going to talk about oncogenes, right? We're going to talk about tumor suppressor genes. Kind of the same thing, right? Actually, it is the same thing. And when you think about those type of genes, right, there's a certain disease that comes to mind, right? It's going to be a leaf-fromating disease, also known as many cancers, right? They get all kinds of cancers, and we have to know P53, okay? P53. And if we use our memory system, right, you know the Cuddy Rank song, Limb by Limb, right? Maybe that'll help you remember it, right? You could say that all your limbs got cancer. Just try to think about it like that. Limb 53, okay? All right, so let's move on. When we are talking about cancer, okay, besides the oncogenes, right, P53, like we said, the big one, okay, there's also a possibility that apoptotic genes could be affected. That's, apoptosis is whereby cells self-destruct. They're no longer useful, but if they're not self-destructing, it can really build up into a tumor, and you can start to have problems. This kind of a tumor, though, apoptotic genes will not be as perhaps malignant and as fast growing as these other cancers, but it could still be a problem, right? Cancer of any kind is not a good thing. So, and also certain cells turn over faster, right? So, like skin cells, right? If you're gonna have a skin cell, those guys turn over pretty quick, right? You're always shutting off new skin, right? I'm probably shutting off some skin cells right there. So, that's just something that can happen. Let's move on. Let's talk about tumor-associated antigens and tumor-specific antigens. Okay? Now, tumor-associated antigens and tumor-specific antigens are important to remember. Listen carefully, because there's also tumor-associated transplantation antigens and tumor-specific transplantation antigens. So we don't want to mix these two guys up. Okay? So let's get this first one associated right here. The tumor-associated antigens, the tumor-specific antigens, right? Tumor-associated antigens has to do with, when we look at a cell, right? One way that we when we look at a cancerous cell, it's kind of like it dials the clock back. It turns from a more defined cell into maybe a more pluripotent cell. That means a cell that's kind of like a stem cell. It can go and turn into many different things, right? It has some of those qualities. And also, that field cells grow super fast, right? That's before we're born, right? The cells grow quickly and they're more stem cell-like. So we can see over here that, right, another name for these types of antigens are also known as oncofetal antigens, okay? Onco meaning cancer, and fetal meaning obviously fetus, right? Let's take a look over here, right? Also, just so we know, in certain select organs, we will also have tumor-associated antigens, right? And just so you know, when I say tumor-associated, okay, that means it's not really completely tumorous. It's like kind of associated, right? So it is normal for us to have a little bit of maybe tumor-associated antigens, right? But if we have too many of them, it definitely signals that there could definitely be a problem, okay? Let's move on to the tumor-specific antigens, okay? This is kind of intuitive, right? If I say the word, it's tumor-specific, well, that means only tumors have those antigens. Now, there's a couple ways that those antigens can be created, right? And actually, we start to get into this business over here with this split, right? How can we create tumors? Okay, we can create tumors through viral infection, right? The virus comes in, injects its DNA, and then it starts to change the way that it may dysregulate, right? What gene? That's right, the oncogenes, right? The tumor suppressor genes. If it somehow interferes with that, and the cell cycle is not controlled and starts to just make copies of itself out of control, it's pretty much cancer. So yes, viruses can cause cancer. I remember this was a debate in my college biology class, right? They were like, can viruses cause cancer? My mom says no, and she's a doctor. Well, hey, you know what? That's science has changed. There's always updates, right? So yes, viruses can cause cancer, right? And the quick one that comes to mind is what? HPV, human papillomavirus, causing what? Cervical cancer, right? So, should just, sounds familiar. I hope it does. Okay, something good to remember. for board tests or just in general. All right, let's move on. So when we take a look over here, right, these tumor-specific antigens, okay, there's a couple different ways that this thing can be affecting the cell. Let's talk about it, okay? The first one is can create new antigens. Obviously, this is probably more likely to occur, right, if you have a virus infection, right? There's new proteins being created, new viral proteins. Some of those may be expressed on the cell surface, and bam, signal to be destroyed, right? Now, let's suppose that there's a mutation, a natural mutation, right? It might change some surface proteins, it might not. But usually the cell inside has its own type of mechanism where it will change the expression of signals on the outside of its cell membrane to let the body know, hey, you know, something's wrong with me, I'm sick, could be cancerous, I could be invaded by a virus, you guys need to destroy me, I need to die for the rest of the community. And they send out these, they attract cytotoxic T cells, they attract natural killer cells, NK cells, right? And these cells are disposed of. They may be also eaten by macrophages, things of that nature, and then they will be presenting on, which are actually known as professional antigen presentation cells. Like I'm getting a little bit far off topic, right? There's you should watch some of our videos for some of those things, but immunology is a pretty complex topic because there's so many interrelations. So it's pretty cool and fun to think about. But let's go back to the subject over here. We're talking about new antigens versus suppressing antigens, right? Some antigens, like I said before, might be signaling, hey, you know, I have this problem over here. But maybe the cancer can say, look, you know, we're not going to express those proteins. Let's get away with our stuff. And that could easily be a way that the cancer could get out of control, right? Your body can't really react because it doesn't see those certain flags or those markers saying, hey, look at me, you know, I'm sick, you guys need to get rid of me, or, you know, that type of thing. Now let's talk about the other guys I was talking about earlier. The tumor-associated transplantation genes, or the tumor-specific transplantation antigens, okay? So when we talk about tumor-associated transplantation antigens, okay, it usually has to do with viral, okay? Because it means that it's kind of like, okay, let's suppose that I took a antigen, like a virus, and then or a cancer type cell, right? And oh my goodness, I have a cancer that's growing on my hand. Kind of gross, right? Okay. Uh-oh, and it's blue. I don't know why. I'm turning into a Smurf cancer. Okay, so I got Smurf cancer right here, and right. Uh-oh, metastasis. Got one over here. Right? Okay. If I check the antigens on this, right, on this guy over here, and I check the antigen markers on this cell, on cells from this one over here, and I biopsy both of these guys, it's going to be the same. It's going to be the same, okay, if it was caused by a virus, because the virus has infiltrated the cell, and now it's causing similar type of, the same cells multiplying itself across my body, right? So, you know, and it could be in my lungs, I could have a little bit of a skin cell growing in my lungs, or in my eyeball, or anything, right? It could spread anywhere. And this is the problem, right? This is a tumor-associated transplantation antigen. But let's take a look at this one, tumor-specific transplantation antigen, and you could see it's so colorful. I added all these colors, and why is that, right? Why is that? It's because, okay? This one, look at this over here. That look familiar? The famous Erlenmeyer flask from Breaking Bad? That's what it is, okay? And what it means is that, let's suppose that I took some chemicals and poured it all over my hand, right? Took these chemicals right here, poured it all over my hand. Oh my goodness, I've developed cancer, okay? Now it's very likely that all these mutagens have affected these cells differently, and there's going to be a whole bunch of different type of antigens. So I take a biopsy of it, right? And even within this particular tumor right here, I'm getting some antigens on one cell and different antigens on another cell. And some of those antigens may have traveled over here. And it's very possible that I, look, more colors over here, right? Here's one over here, and here's one over here, right? Look, and I'm gonna look too crazy when I go to class tomorrow. All right, but yeah, I have almost even two types of cancer, right? Two different types of cells here, and there's two different types of cells here, right? There's one, that one metastasis here, another metastasis here, two different kinds of these guys, and that is known as tumor-specific transplantation antigens, okay, caused by chemicals. So it's not really that intuitive because if you see the word specific, right, you think specific means it's this one type of thing. But specifically it means this one and specifically this thing. Okay, I hope that helps you to remember, okay? Tumor-specific transplantation, right, it's transplanting. Okay, that's how we're going to keep the difference between this guy and this guy over here because, oh my goodness, they sound kind of similar and I'm ready to mess this up on a test. But I hope you don't. Okay, let's talk about a little bit more before we go on to talk about some of the qualities of tumor-associated antigens. Let's go back and talk about tumors themselves in general, okay? We're going to look at this over here. This chart over here, okay? Let me label it, okay? This is going to be age. Okay? And this is going to be cancer. Okay? So basically what this means is I'm more likely to have cancer when I'm very young or when I'm older. Okay? Why is that? Okay, let's talk about it. Well, obviously as time goes on, we're going to get exposed to more viruses and, mutagens like sunlight and tobacco smoke and chemicals, and these things will cause cancer. But wait a minute, when we're all young and fresh, why are we having more cancer? Well, as you may know, when we are babies, we don't really have a fully developed immune system. So we can't really fight off cancer the way maybe that someone with a more developed immune system can. Okay? So that's one reason why cancers can take off easier when you are a baby. Okay? Also, just so you know, if the tumor has a high lymphoreticular infiltration, right, you're more likely to survive. And that may seem kind of strange and not completely intuitive at first, okay? Let's suppose that I have breast cancer over here, okay? These breasts right here, okay? And a lot of times when they remove the breast, okay, they'll also remove some lymph nodes here, maybe, like, to prevent metastasis to the other breast. And they'll also remove some lymph nodes over here in the axillary area, right, under the arm. And, the reason for that is because that's how the cancer kind of spreads, right? The blood is carrying all the liquid out, right? And then there's extra fluid, right? Not all the blood, if we're talking about plasma, right? Not all the liquid that's in the blood goes back into the veins. Some of it comes loose, like in the tissues, and it's sucked up by the lymphatic system. And the lymphatic system goes into these nodes, which act as filters, and actually that's a lot of places where cancer cells end up going and spreading to the rest of the body, right? So this is actually very problematic. Now, so you're thinking to yourself, right? Well, if the lymph vessels are where the cancer spreads from, and the cancer is right by the lymph node, doesn't that mean that the cancer is actually super happy because it can spread itself to the rest of the body? Yes, that is true. But, okay, let's take a look at why your body is sending things through the lymph nodes. Okay, the lymph nodes are actually the place where it's actually known as a secondary site of the immune system. The primary site might be, the bone marrow and the spleen, right? But actually we're talking about, in this case, the lymph nodes, right? There's a very high density of immune cells, talking about white blood cells, that are in those particular sites that are filtering and destroying bad guys. And guess what? Cancer's a bad guy. So it just happens to be by all the defenders, right? It's basically like the gates to the rest of the body, right? So it's right by the gate, which is good because if it can break through the gate, it can spread itself, but by the gate are all the guards. And if they're really infiltrated, if there's a lot of guards around, they just might not survive, and you have a better prognosis, okay? So that's just to help you with a little, maybe not 100% intuitive idea. Let's move on. Tumor-associated antigens, okay? Remember that tumor-specific antigens, right? We test for these and you definitely got it. It's not, it's obvious. But maybe there's some tests that we can give you, right? To see if you have cancer, right? And they may be tumor-associated antigens. Let's talk about some of them. Afp Alpha-Fetoprotein. Does that sound familiar to you? It should, okay? By this time in your career, you probably have studied a little bit about what? The liver. Okay, remember AFP is actually a liver test, okay? By the way, alpha-fetoprotein is secreted, okay? And the normal secretion of that is going to be 0 to 20 is considered normal, and if the level is above 100, this suggests liver or testicular cancer. Okay, so you can see over here, down here, I like to draw my little things. Okay, I'm not much of an artist, but you know, hey, I do what I can. Here we see this guy over here. Okay, we're going to concentrate on this guy over here. This is the alpha. Look at this alpha right here, right? And he's a baby. You see this pacifier in his mouth? Okay, he's got 2 lips over here, right? And this thing kind of looks like a 0, right? So we can remember 20, right? 20 is normal. This is a normal looking baby right here. Alpha-Fetoprotein, right? Fetus, he's not quite fetal, he's kind of a baby, fetal-like, right? Alpha-Fetoprotein right here, okay? Now we're going to talk about his buddy, carcino, okay? And this is carcinoembryonic antigen, okay? Carcinoembryonic antigen actually occurs on cell membranes and secreted fluids, and this is actually something that we want to remember, okay? Because the thing is that, okay, the fact is that if the antigen is presented on cell membranes, it's kind of like more important for the immune system, right? The immune system, if it sees it on a cell membrane, it'll actually take activity. It'll either have MAC attack, right, through the complement cascade, that means membrane attack complex, or it will be able to stick the antibodies on and then mark it for destruction in different ways, right? Through phagocytosis or, you know, agglutination or, you know, other things, right? Basically, that's, you know, shooting out the superoxides, right, to just basically kill it. You know, the granulocytes. Hope this is all ringing a bell? Okay. Hope so. If not, check out our other videos, okay? Alright, so let's get back to it. Cell membranes and secreted fluids. 0 to 2.5 is normal, and 10, if it's up by 10, okay, then it's colorectal cancer. So look at this guy right here, okay? He's got, okay, this gun right here. Okay? And it's not a 22. We look at the muzzle, it's very short, right? I could have made it this long, right? Like a big rifle, I didn't. It's not a 22, right? A 22, if you ever held a 22, you could go Google some 22s. 22 is probably, like, honestly, like, fit in my hand right there. It's a very, very small gun. A 25 is a little bit bigger, okay? And this guy has a little gun right there, and it's a 25, okay? And by the way, carcinoembryonic antigen can go up with smoking. Look at this guy, he's smoking right here. Around a baby? Are you serious, man? Oh well. Okay, we know it's potentially bad. Why? Because babies are more likely to get cancer, right? They don't have the fully developed immune system. Don't be smoking around the babies, man. Carcino. Alright? Well, luckily it's just a drawing. Okay? Look at Carcino though, right? He's not very mature, is he? He's kind of a jerk, right? And he's wearing this big diaper. Okay. You know, you act like you're 10. That's how this guy acts, right? He looks like an adult, but he acts like he's 10. Maybe even less than that, because if the levels are 10, that means he's going to have possibly colorectal cancer, right? Colorectal cancer, we're thinking diarrhea. Okay? So, yeah, just remember this guy, you know? Carcino and his buddy Alpha-Fetoprotein. And let's go to the end of this particular topic, and let's talk about how tumors can fight back. Okay? Tumors, we talk about some of the ways we can test for them. We talk about you know, how they invade and how they get things done. But the immune system, we know, is going to start mounting defense, right? How is the tumor going to outpace the immune system in order to win the war? Well, what they can do is they can grow fast. Okay. The thing is that when tumors start, they're creating small amounts of antigen. Maybe they're even creating. Maybe they don't even really technically have antigen. Well, okay. Remember before I said that the cell has certain markers, certain flags that they'll be presenting? Even if the cell doesn't present those flags, right? If the cell is missing those flags, it's still abnormal. And the immune system will sense this, right? Even if they don't have any MHC complexes at all, right? MHC is how antigen-presenting cells present, hey, I got a problem here, right? But let's suppose that the cancer says, oh, you know what? Through a special cancer, we're going to disable all the genes that have your MHCs pop up. You don't have any MHCs, NK cells are kicking in, they're still killing them, right? But the response might be slower. You know, I mean, you kind of disabled one defense mechanism. And so you have a lower response system, and then you have this cell dividing like crazy, because that's what cancer does, and outpaces the immune system, and it's too late. they've outgrown you and they basically won the war. Number two, oh, look, I just talked about downregulating MHC or other T cell activators, right? Well, look, it could be a combination, right? It doesn't have to be just one or the other, it could be both. I hope this video was helpful for you. I know it was helpful for me. Thanks again. Alright, that's it. Thanks for checking out SGU TV. Please make sure to like, comment, and subscribe, and check out our other videos.